So far, we went through the background, foundation, and the hotel towers. Today, we are going to start about another structure built on these, the Sky Park. Let's review what we've learned so far. We talked about the problems and solutions of the project, such as reclaimed land, weak soil, diaphragm, and many other construction methods. And we could complete the foundation of the hotel successfully. To overcome the slope of the building's lower part, the engineers used the vertical forced tension method creatively, so they could prevent the collapse of lower part. Since this technology has never been tried, temporary bracing was used as the building lies, to reduce the possibility of failure more surely. Go up, prop 2, and go on. Prop 3. And this is the picture of struts installed. And transfer truss was installed on the 23rd floor. This transfer truss permanently reduces the load transferred to the tilted structure. It delivered a 40% of load to a tilted structure. We studied the actual load distribution last time. After this, the building could go up safely. After transfer trusses were installed, the temporary struts were removed and they were able to provide attractive empty space for people. Finally, the building overcame a lot of challenges and was safely built up to the 55th floor. And now, it's time for us to move on to the next phase. Sands Sky Park has many facilities such as food outlet, infinity pool, sun deck and lounge, gardens, nightclub, food outlet, and observation deck. The boat-shaped structure, including all of these facilities, is covering more than 10,000 square meters and weighs more than 60,000 tons. It's 340 meters long and 38 meters wide. This is almost 4.5 times the Air Force A380 model's length. To find out how huge this structure is, let's talk more about the facilities. There are 2 restaurants on both ends. There are sun deck and lounge. There is a nightclub and people's movements produce vibration. There are landscaped gardens having more than 500 trees and more than 3,300 tons of soil. There is an infinity pool where the water appears to have no boundary. It's 150 meters long, covering more than 1,400 square meters, and containing 1.4 million liters of water. And the observation deck. It is the longest habitable cantilevered structures in the world. It's longer than 66 meters and weighs 3,500 tons. It offers visitors a 360-degree view. Including all of this, the huge boat-shaped structure links, links three sloping buildings together on top of them. Imagine that. The Eiffel Tower is placed on the Marina Bay Sands hotel towers. You'd understand how ridiculous it is. How does this giant superstructure cross three buildings 200 meters above the ground? Let's study about the structure of that. This is a drawing of Skypark's structure. The four-movement joint split the Skypark into five distinct sections. Three of them are two steel frame of building and one steel box gutter bridge. They are supported by the hotel towers. And two sections are bridge sections that connected by three main steel trusses. The five distinct sections are isolated each portion laterally. The skypark elements are connected to allow for differential movement of the towers under gravity, wind, and seismic loads. So, what is the movement joint, and how can it control differential movement of towers? Left picture shows positions of movement joints and bearings indicating their direction. Movement joint, also called expansion joint, is a structural gap designed to accommodate the movement of a building in a controlled manner, preventing damage. This is commonly used in bridge construction. Movement joints of Marina Bay Sands Sky Park are inspired by bridge engineering technology. This shows how the movement joints work in the sky park. They can move back and forward over each other. To accommodate the differing movements of the three towers, engineers also installed multi-directional steel bearings below the sky park. This is a rear picture of movement joint used in Sands Sky Park. The following table shows the maximum anticipated movement. Gravity 150 mm. It's irreversible. Wind 250. Seismic 600. And they are reversible. Now, let's see the Sands Sky Park steel frame. 7,700 tons of steel were used in the Sky Park's construction. Also, 4,400 tons of temporary steelwork were used. Please look central cores and W-shaped structures carefully. Central lift cores. Central lift cores of each hotel tower penetrate through the sky park to provide comprehensive lateral resistance. They connect the steel structure and the composite slab, acting as diaphragm walls. You can also use it to go up Sky Park from the hotel. It is also a major structure that provides lateral load resistance structurally. And this is a V or W-shaped column that supports Sky Park. Once installed, these are invisible from the outside. Basically, these three zones are connected to the hotel building, allowing the load to be delivered to the lower structure. By using W-shaped columns and central lift cores. Now, let's think about the bridge sections. As you can see, there's nothing under them. Literally, that huge structure is floating in the air. How is it possible? The bridge sections span over 50 meters between the towers, and the section comprised three longitudinal steel trusses. In more details, from the top, the segment number is A1, A2, A3 in order. The truss looks like this. Their length and weight are as follows. All segments are huge structures that exceed 300 tons and 50 meters. The bridge 2 is also similar to the bridge 1. From the top, A4, A5, A6. Their length and weight are as follows. All segments are huge structures like bridge 1. And the cross-girder beams are placed approximately 4 meters apart, supporting the composite slab. We can now anticipate the load transfer of the upper structure. On top of them, on top of three slanted buildings, the Sand Sky Park is placed. Its length is 340 meters and laid 200 meters above the ground. Two bridge sections, divided by movement joints, connect the hotel towers, as if they were floating in the air. And the vertical force is applied by gravity. The truss then carries the load to the building. The carried load go down along something called shear walls and are transferred to the foundation safely. As a result, they are kept safe. Then, how can the cantilever structure be maintained in the air without our support? Does it look short? Let's see other pictures. This observation deck is the longest cantilevered structure. It's definitely very huge. Let's see the cantilever again. There's no support except for the part connected to the building. Longer than 66 meters and weighing more than 3,500 tons, it's massive and huge structure, and as you can see, it's in the air without any support. Then, why doesn't this structure collapse and fall down? We will discuss about this cantilever structure and how it was built 200 meters above the ground next presentation. See you next time. Thanks.